Hey, welcome back, sixth graders. I hope you enjoyed the assignment. Not too many problems. It shouldn't take us that long, although we do have to do some multiplication. So let's get started. I want you to be in this great habit, Mr. Brennan, and this is lesson 8.4 on page 378. Okay, we're going to start with number 2. Will the formulas for volume work for a rectangular prism? Well, we know the formula for volume is really easy. It's just length times width times height. So the answer is yes. The formula will work. And just like I showed you with that little cube a few minutes ago, um, it's always going to work. You're just going to go length times width times height. So it doesn't matter if it's a decimal or it doesn't matter if it's a fraction. This doesn't matter. It's always going to work. Okay, number 4. Let's do some work. Find the volume of the prism. So right away, they're going to give us fractions, which is great because we know how to multiply fractions. We've been doing this since third grade, or I'm sorry, not third grade, fourth grade and fifth grade. So I'm just going to go this one times the length times width times height. It doesn't matter which one is going to be first. We know the commutative property. So I'm going to say 2 times 3, or 2/3, sorry, 3/5. 2 times 3 is, well, should I cross cancel? I'm gonna. Is that okay if I do? I know, because this is the same as 2 over 5 times 3 over 3. Because 2 times 3 is the same as 3 times 5, no matter which one comes first. So I'm gonna do this cross canceling one. So that gives me 2/5 times the last one is 3/4. So I'm gonna do this 2/5. Another great place to cross cancel or divide early. So that's going to be 1, and that's going to be 2. 3 times 1 is 3. 2 times 5 is 10. So the volume of this prism, so I did 2/3 times 3/5 times 4 times 3/4 is 3/10. I'll work that another way for you. 2/3 times 3/5 times 3/4. No fancy cross canceling, anything like that. I'm just going to go 2 times 3 is 6. 6 times 3 is 18. Then on the denominators, 3 times 5 is 15. 15 times 4 is 60. And now I've got to reduce this. So that's a little bit tricky, huh? So I've got to figure out a number that goes into 18 and goes into 60. I think that number 6. 6 is going to go into 18 3 times. 6 is going to go into 60 10 times. So you see we got the same answer here. We just took a few shortcuts here that you should be pretty familiar with. So, and that because that's going to be 3/10 inches to the third power, inches cubed, because it's 3 dimensions. It's length times width times height. Dimension times dimension times dimension is 3 dimensions. All right. I think you get it. If you don't get it, call me on the phone. Same thing, only this is 2/5 cubed, huh? 2/5 times 2/5 times 2/5. I'll write it out for you. 2 times 2 is 4 times 2 is 8. 5 times 5 is 25 times 5 is 125. Now, is there a number that goes into 125 and 8? Not 2, not 3, not 4. So I'm going to say no. Not that I know of. Feet cubed. Number 8. You see number 8? Maybe you look in your own book. This is a little trickier because instead of just fractions, they're giving us mixed numbers, but I'm going to write the whole thing out again. 2/3 times 5, 6 times 2 and 1/4. So we know that when we multiply or divide mixed numbers, we got to turn them into fractions. So I know that another name for 1 is 3/3. So this one is 5/3 times 5/6 times another name for 2 is 8/4. So this is 9/4. Can I do my quick cancellation here? Divide before, instead of doing what we did up here and multiplying first and then trying to do a bigger division problem like 18/60. I can say, well, look, I know that 3 goes into 3 one time, 3 goes into 9 3 times. So I'm going to reduce that 9/3 into 3/1. And then I can go again, because I know if 3 goes into 3 one time, and it goes in there 2. So my math just got a lot easier. I got 5 times 5 equals 25. 2 times 4 is 8. So in the end, I have 25 divided by 8. And I know that 8 goes into 25 3 times with 1/8 left over. Come back to my problem. That is cm's cubed. Not squared, but cubed. All right. Can you see my book? Let's move you around here. Let's move you over here. Number 10. Write and solve the equation to find the missing dimension of the prism. Okay, so we see this is a prism. 9 times 9 times h is 16. So I've got 9 times 9 times h, and that equals the volume is 1620. So I know we just did this a little bit of algebra in the last unit. Kind of fun, I think. 9 times 9. So I got 81h equals 1620. So now I have to divide both sides by 81. So 81 times h divided by 81. 81 times 81 divide is going to be h. And I should be able to figure this out, but I'm going to cheat, use my calculator. 1620 divided by 81. 1620, sorry about that. Divided by 81. Can you see that? No. It's 20. So h equals 20 cubic centimeters? No, just 20 centimeters. Because 9 times 9 times 20, or times 20 is 16. Is that right? Yeah. Okay. Let's see, number 12. Can you see that? Maybe. Same type problem. I know that 1 3/4 times 19 times W is equal to 532. So what is 1 3/4 times 19? I don't know that. So I'm just going to change this to, I know another name for 1 is 4/4. This is 7/4 times 19/1 times W equals 532. What's 7 times 19? Boy, this is a brutal problem. 7 times 19. 7 times 19 equals 133 fourths times W equals 532. So what is 133 divided by 4? It's not going to be an even number. It's 33 and 1/4 left over times W equals 532. Uh-oh, you can't see what I'm writing. Sorry, I got started having fun. So now I'm going to divide 532 32 divided by 33.25, 33 and a quarter, and that's going to leave me with W equals 16 inches. Okay, let's move over to the next. So I hope this is not too hard. The idea is the same. It's just length times width times height all the time. It doesn't matter. It shouldn't matter if we got decimals or fractions or anything like that. It really doesn't matter. Oh, this is the fish tank. I wish we could do this. I love the fish tank problems. How many 3/4 centimeter cubes do you need to create a cube with the edge length of 12 centimeters? So let's see. I know some things. Well, maybe I won't show all the things I know. I know that if I've got a cube, that's important, and it's one edge is 12 centimeters, then all the edges have to be 12 centimeters. So to get that cube, let me find the volume of the cube. 12 times 12 times 12, and I know that 12 is 144. Every little kid used to know that back in the peachy days. Times the other 12, and that's going to give me 1,728. Now, that would be the answer if I was using just single cubes. How many cubic centimeters? This how many cubic centimeters. But I know that it's going to be a bigger number than that because I know that I have to divide by this 3/4. How many? I would just divide by 1 here, but divide by 3/4. And I call that 0.75 because I'm going to use my calculator. You could do it by hand if you want, but I'm not gonna. So 1728 divided by 3/4 equals, now be super careful here because you're going to think that that's the answer, but because I'm in 3 dimensions, I have to divide that by 3/4 again. Okay, and that equals divided by 0.75, and that equals 3,072. Are you still being careful? Because I've done 1, 2, and I get to divide by 75 hundredths or 3/4 again. Divided by 0.75 equals 4,096. 4,096 what? Centimeter, 3/4 centimeter cubes. Cubes. Okay? You could just write cubes. So now this problem here, that's brutal. You're never going to see a problem like that till you're in high school. So I remember seeing this in the book last week and thinking, that's funny. So sorry about that, but that's the answer. If you put this as an answer, that's a good start. That would be normally the question you would have. So let's just move on with our lives. We'll forget this ever happened. I'll get a food one. Estimate the amount of casserole left in the dish. So it looks like about 25% is gone or a quarter. Will the casserole be, I wonder if it's enough to, oh, I see what they wanted to do. So A, about 3/4 are left. And B, they're going to make us calculate, huh? Will the casserole fit into the storage container? So if I find the volume of the whole thing, and then I'm just going to subtract a quarter of it, or multiply by 3/4, and then I can see if it fits in there. So let's figure this out. I'm going to figure this out. 2 3/4 times 12 times 12. Well, we already know that 12 times 12 is 144. But what another name for 2 is going to be 8/4. This is going to be 11/4. Can I do this really quickly? No, I probably can't. 11 divided by 4. Oh, 11 divided by 4 is 2.75 times 144, which is 12 times 12. That's going to get me 396. Now that's 396 cubic inches if I did the whole thing, but I'm going to take 3/4 of that because remember I'm minusing 1/4 times 75 hundredths. So right now I've got 297 cubic inches of casserole. Well, that seems like a lot, huh? 297. But that's what we figured this out thing was 396 for the whole thing. So it should be easy. 12 times 12 is 144 times 3 is going to be more than 300. So that's right. Now I got to find out 7 times 7 is 28. 28 times 4, I probably should have that in my head, is 112. So the container, sorry, I can't reach camera. Container is only 112. Will the casserole fit in the storage container? Explain your reasoning. So the answer is no, because I would need 2 of these, 3 of these things. I have 297 cubic inches casserole. It's greater than 112 cubic inches of container. Okay, number 18. So number 18 is one of my favorite problems in this whole book. If we were at school right now, you're gonna feel like you dodged a bullet. If we were at school right now, we'd be designing tree houses, and we'd be looking at this for probably 2 or 3 days, this one problem, because it's a good one. Most kids put really poor answers. I was going to show that on the last Zoom, but we didn't have time. So you have 1,400 square feet of boards to use for a new treehouse. Design a treehouse that has a volume of at least 250 feet, cubic feet. Include sketches of your treehouse. So most kids just put I don't know, or I can't make a sketch. So, but you at least need to have some way. So let's rewrite this. I know that it's got to be, I've got to use less than 140, I'm sorry, 1,400 square feet. So that's got to be greater than my surface area. I'll call that SA for surface area. Okay, and then I know that 250 cubic feet. I'm sorry, this was feet squared. This is cubic feet. It's got to be more, and that's going to be, we'll just call that V for volume. So those are the 2 things that I need to know, and I need to come up with some. I needed to come up with a treehouse. So I need the length times width times height equals the volume. So let's see. Let's just, what are we thinking here? Let's say a treehouse has got to be 8 feet tall. Don't you think? There's a way I could do this. When I first did this problem, I took that 250 and I divided by 3. But I know that there's some tricks here. Let's just say, let's make it easy. 10 times 10. Okay? So that's easy. 100 times 8 is 800. 800 square feet is 800 cubic feet, sorry, is greater than 250 cubic feet. So, but now, do I have enough wood for that? Well, I'm going to tell you that lots of people's tree houses, so when they were making them, the length and the width was like 2 feet by 3 feet. So you imagine that. You'd have to be standing up there with your best friend. You couldn't sit down. You couldn't move, even though 5 feet by 5 feet. My question that would take so long is how big of a tree house can we make if we've got this? Does this, so I'm going to draw a picture. Let me draw a picture. This could be the front because it's 10 feet tall. 10 feet wide, so I know that's 100. That means that this part that goes back is going to be 8 feet. Oops. Didn't do a very good job of that. What did I do wrong? I made that too far. Okay, that's good. Anyway, so that means I've got the front and the back face are 10 times 10 times 2, because I've got this one, and then I've got I've got this one back here, right? So I've got those faces, and that, we'll just do the math. 100 times 2 is 200. Then I've got this one, 10 times 8, and I got 4 of those. I've got this one, 10 feet tall and 8 feet wide. I've got 4 of those. So 10 times 8 is 80. 80 times 4 is 320. And that makes 520. So we've got a pretty good sized treehouse here. And there's a ton of room, right? I haven't even used nearly half my wood. So if we were going to play this game, you could make a lot bigger treehouse. You can make a treehouse as big as your living room, just about, depending on your living room, bigger than some people's living rooms. So it's funny that a lot of kids made these super tiny, tiny, tiny little tree houses. If we had a chance to play, we would make these big tree houses. Okay, let's keep moving. Number 20, one of my favorites, geometry or algebra. Tell whether the given value is a solution of the equation. X divided by 5 equals 6. I'm just going to write that, because it makes so much sense. If you're just putting answers in the computer, you're doing it wrong. You got to write this to learn it. And the only reason you're doing this is to learn it, not to get a mark in the grade book. That's just silly. So can I substitute 35 for X? That means 35 divided by 5 equals 6. And I know that that is true. Yes, true. It's awesome one. And the last one, number 22. Which set of integers is ordered from the least, that means the smallest, to the greatest, that means the biggest? Let's take a look at A. -1's good start. 3, so far. Oh, 5 is less than 1, so it's not A. -1, yeah. 3, sure. -5, oh no, not again. How about C? This is looking pretty good. -4, yeah. 2 is great. -2 is greater than -4. 1, sure. 7 is greater than 1. 10 is greater than 7. I like C. I'm going to keep my finger on it. Now let's look and see if maybe D isn't the correct answer as well. -14, -9 is greater than -14. 6 is greater than -9. Oh, look at this 4. So that would come back to my finger. The answer to number 22 then is C. -4, -2, 1, 7, and 10. Okay, you probably didn't need to write that. But anyway, I hope you enjoyed it. This problem here, number 18, one of my favorite problems. Number 14, I didn't know. I didn't know if you're going to figure that out by yourself. These kind of problems here, you should be good at this. Multiplying mixed numbers, that kind of thing, dividing. This is stuff in 6th grade. So I hope you enjoyed the work, and I'll see you tomorrow.